In this video, we want to combine our drawing of vectors that we did in Vectors 1 and our measuring and getting the direction and magnitude of the resultant that we did in the Vectors lab, where we did that with a ruler and a straight edge. We want to combine that with what we did previously with our triangles to try to solve these vector problems by just using our law of sines and our law of cosines. So here's our first problem. A force of 30 newtons is pulling an object due south. Another force of 15 newtons is pulling the object in a direction of 60 degrees. Find the direction and magnitude of the resultant. Now, as with all these problems, one of the most important things is our picture. So let's start off with our first due south 30 degrees. There is our first vector. Now, to help me out, I always think on all these problems it helps to always put kind of that north, south, east, west there. But our other vector is 15 newtons, that in pink, at a direction of 60 degrees. So it's about half the length. It's going in that direction. 15, and this angle here is 60. So, first thing we need to do is draw a parallelogram. So we'll draw our parallelogram, and it's fairly easy to do on the smartboard for me. I can just recreate these lines to make my parallelogram nice and straight. And then I can get my resultant, and I'll make it this blue line that goes from there to there. So this is my resultant. I'll call it R that I'm looking for. And we will say this side is also 30, this side is 15. Now, we need to use all of our rules that we know of angles to try to figure this out. And if I know this angle is 60, I know this angle right here is also 60 because I have a vertical line, parallel lines, corresponding angles are equal. So I can find R with my law of cosines. Most of these problems, our first step is going to be to use law of cosines. So for that reason, what we're usually looking for, the angles that we're looking for are the angle between the two sides. That's our important angle. So once we put that into calculator, I'll also say, once again, I really like just typing all these in at one time. I think it alleviates a lot of the mistakes people get by typing things in. Second answer. And we get 25.981. So that is our newtons of force. So that's how many newtons are being of the result of these two. The next thing we need to determine is what is the direction. Now I'm going to do this by looking at the bottom triangle here. I'm going to find this angle right here. So that gives me the sine of 60 over 25.981 equals the sine of theta over 15. And if I do that on my calculator, I get 15 sine of 60 divided by 25. I'm just going to do answer, which gives me that. And anytime you want to find an angle, you always have to do sine -1, only when you're finding an angle, and I get 30. So that tells me my angle is 30 degrees. Now, that's in my diagram that this theta is 30 degrees. To actually find my direction, so I'll say my magnitude is 25.981 newtons. In my direction, I'm going to say south 30 degrees east, or I could just say 150. Because if you look at my angle, this angle all the way around, if this is 30, this angle is 150. So either of those two answers is okay, 150 or south 30 degrees to the east. Let's try another one. Two tugboats are pulling on a boat. So we will say right here is where our boat's at. It's the star right in the middle. Okay. One boat is pulling at east 10 degrees north at 10 knots. So we will say right there. And this is 10 degrees, and the length is also 10. The other boat is south 20 degrees west at 8, so it's a little bit shorter. My angle's a little bit more, but this is 8, and my angle is 20. Notice I'm not really necessarily drawing these perfectly to scale. If you want to get a protractor and a ruler, you can, but not really necessary. Oops, sorry. I'm going to draw my parallelogram. There's my parallelogram. I then draw my resultant, the diagonal, right there. Now, I need to find some angles. So this side is 10. So what angles can I find? I'm trying to find the angle between them right there to do law of cosines. Now, what I'm going to do to help me is I'm going to bring out another graph here. And I'm going to put this right here at this point. Okay. Now, I know at this point that this angle's 20, so I know this angle's 20 right here. I don't know if you can see that. Two vertical lines, opposite interior. I also know from up top that this angle down here is 10. So I know 20 up here, 10 down here. That tells me that middle angle is 60 to find R. So once again, R squared is 8 squared plus 10 squared minus 2 times 8 times 10 times cosine of 60. And if we do that on a calculator, 8 squared plus 10 squared root the answer 9.165 knots. Now we need to determine the direction. So what I'm going to find next is I am going to find this angle of my triangle right here. Now, I don't know if I can see that there. I don't think there's any way to really blow that up. But I have my two sides like this and my dotted line coming down. This side is 20. And I want to know this side for my direction. If you look at it, this is the pink, this is blue. Oh, blue. So, I'm going to find that angle. So I have the sine of 60 over 9.165 equals the sine, I'm going to call it alpha, because I'm going to call this whole angle alpha, over 10. So if we do that on the calculator, 10 sine of 60, divide by that, inverse sine of my answer, I get my alpha to be 70.89. So this alpha over here is my 70.89. But that means my theta is 50.89. So my magnitude is 9.165 knots. And my direction is going to be south 50.89 degrees east. You can see a big part of this is getting your diagram big enough to see what's going on and also clear enough to see what's going on to find your answers. Let's do one more. A force of 10 newtons is pulling an object east 10 degrees south. Another force, 15 newtons, is pulling an object in the direction of west 25 degrees south. Find the direction of magnitude. So let's bring out our north, south, east, west kind of thing here. We have our 1 east 10 degrees south of 10. And we have another 15 west 25 degrees south of 15. So I'll label them like that. This is 25. This is 10. And we now need to draw our parallelogram. Like I keep saying, it's very easy to do here on Smartboard because I can just cut and paste these nice perfect lines. It's a little bit harder when you don't have that. So somewhere down there. I don't know if it's straight south or not. It's kind of hard to tell. So let's see. What do we know? We know that this side is 15. This side is 10. This side's 10, this side's 15. I'm trying to find blue, so I'm going to put these here just to think about where these are at. Okay. I'm guessing it's a little bit over there. So let's see, what angles do we know? Well, we know this angle is 25, opposite interior, and we know this angle is 10. That's where it helps kind of putting these dashed lines everywhere. You can see this green line and this green line are the same. From the horizontal, that's 10. So my big angle is 35. So if I want to find my resultant, r squared is 15 squared plus 10 squared minus 2 times 10 times 15 cosine of 35. And the length of my resultant this in the calculator. Take the square root. 8.902. So there's my force in newtons. My magnitude. And now you find the direction. And this is the hard part. Let's find this angle right here. theta. So I have the sine of theta over 10 is equal to the sine of 35 over 8.902. So let's find what theta is. So that gives me 10 sine of 35 divided by 8.902. I'm trying to find an angle. So I do inverse of my answer, and I get 40.115. Now, if we look at this drawing, I have 25 here plus 40. So let's add 25 to that. I get 65. So my angles here are not very accurate. I think my 25, if we actually measured here, this is where it might help. If I actually measured my angle of 25, you can see I'm actually closer to 40 than I am to 25. So my angle's off. This angle right here is too big. So what that does is it messes this up. So it's hard to tell where I'm at. So I'm 40 over. So we said that gives me a total then of 65.115. So that's my from over here all the way down to there. So it's not as far straight south as it looks. So I'm going to have west 65.115 degrees towards the south. So it should be maybe a little bit more about here is where it should be, but the way it worked out, the way I drew my picture, it wasn't very accurate. That's why it's important. You just always trust the diagonal of which way it is or where it's at, and you just find your angles in your triangle to try to get your answer. All right, you're now ready for homework on vectors 2.